Hello everyone and welcome to the Drydock episode 362. This week the questions taken from guide 430 on the Type 7 U-boats and the Wednesday video on Forgotten Theatres looking at the Royal Navy's Indian Ocean strategy in the interwar period. So let's begin. Eric Van Dooting asks, with regard to the sinking of Taiho, lack of proper damage control training and the fact her avgas storage tanks were so susceptible to shock damage were fairly clear flaws. But what about the fact that her lift wells extended below the waterline when she was fully loaded? Could you please explain what additional risks in suffering damage or difficulties in controlling damage this feature caused? In and of itself, the fact that Taiho's lift wells went below the waterline when she was at full load wasn't a huge problem. There was some issue, particularly around the fact that obviously if she did take damage under the water and it was quite extensive and therefore there was flooding, if that damage managed to flood the area around the lift well and thus potentially also flood the lift well, which was fairly likely, then in theory, if the ship became progressively more and more weighed down, perhaps by further damage, then the water could bubble up through the lift well into the lowest part of the hangar decks. And, well, those tend to be fairly large areas, which would probably doom the ship if they started flooding uncontrollably. However, the specific situation in which you have damage that extends far enough into Taiho below the waterline such that the flooding reaches the lift wells, and you get other damage that's significant enough to start dragging either the bow or the stern or whatever down far enough that it starts overwhelming the hangar deck. While it is a design flaw, it's also more of a problem of you have holes in your ship that are big enough to let in that amount of water, you're probably going down anyway. It's just this will make it slightly quicker. However, in the particular circumstance that Taiho found herself in, a different factor, namely the shattered aviation gasoline storage tanks, combined with the lift well issue to create a perfect recipe for disaster, because of course hydrocarbons, petrol, oil, etc., lighter than water, therefore float. And so what happened with Taiho was that you had a big hit, okay, water bubbles up through the lift well, not necessarily too much of a problem because the flooding is controlled and contained, it's not coming further up, so you don't have an uncontrolled flooding scenario. But then the aviation fuel obviously mixes with the other liquids, mostly water, in the flooded area, rises up, and has a natural outlet sitting in this little pool at the bottom of the lift well. And as it sits there on top of the water, it starts to vaporize and it wafts up into the rest of the hangar, and then eventually click and boom. So that was the particular problem there with Taiho. So, as I said, you had in and of itself a generic risk of somewhat faster uncontrolled flooding, but I would say probably mitigated somewhat by the fact, as mentioned, that if you do have that degree of flooding, you're dead anyway. It's just a matter of when. But it meant that when you have a situation specifically like Taiho faced, not only did it provide an outlet for the aviation fuel tanks to leak internally within the ship, which may not have happened otherwise, or at least might have been better contained otherwise, but it also meant that pretty much no matter what you did, you were going to continue filling those hangars and anywhere else that you ventilated the air to with a fuel-air explosive mixture for as long as those gasoline tanks were still leaking gasoline. Because, of course, you fill the hangars, someone does something for ventilation and disperses that. Well, you've got a massive puddle of aviation gasoline at the bottom of the hangar. It's just going to refill itself. And that obviously turned out to be a fatal problem. BK Zhong asks, did the Germans ever try to get input for proper surface ship designs from the other Axis powers? To a certain degree, yes, but with mixed success. So, for example, with their aircraft carrier program, obviously Germany had no experience of building aircraft carriers. Italy didn't either, so that was out. They made a few attempts to covertly or semi-covertly get information from the UK, but the UK was fairly good at not showing them any of their latest stuff. And so they ended up going to the Japanese, and they ended up getting some information about the Akagi. The only problem was for the Germans was that while it gave them some general principles, the fact was ultimately Akagi was a very, very large converted battle cruiser, which didn't necessarily tell them everything they needed to know about purpose-built and purpose-designed aircraft carriers. If you wanted that, then they would have been better off getting information, at least given the time period that they asked about Akagi, probably asking about either information about Ryujo, which they could upscale, or Hiryu and Soryu. But the Japanese were kind of playing their cards a little bit close to their chest and giving them information, but also at the same time not giving them particularly useful information. And this is something of a trend when you look at Axis tech sharing, apart from, towards the middle and end parts of World War II, when it becomes very clear that everybody's exceptionally desperate. But in the interwar period and the early part of World War II, the Axis powers notionally should share, but it's almost always in the context of, well, what can you give me in return? And even if they can work something out at that point, it will very often be a case of, well, I'm going to give you the absolute minimum possible and hope that I can extract the maximum out of you, which kind of aligns with the three countries authoritarian, everything for me, nothing for everybody else mindset. And once the Germans had cozied up to the Italians and Mussolini, there again was an attempt at various points by both sides to get various shipbuilding and sub-building secrets and tips from each other, but you usually ended up with either refusals or quid pro quos that couldn't be met, or again, very minimal transfer, or promises made but not promises kept. And the other thing was that as time went on, German designers, because they had a few ships now under their belts, became more and more convinced that they didn't perhaps need outside assistance quite as much, which was obviously a little bit unfortunate, because while to a certain degree you can excuse the design flaws in something like the Königsberg class due to the various pressures and restrictions they were under thanks to the Versailles Treaty, once you get to the massive monument to inefficiency that is the Admiral Hippers and some of the other mid to late 1930s ships, well, by that point they've already started building the Scharnhorsts, they've constructed a bunch of other smaller craft, destroyers and so forth. The Deutschlands have been built, as you can see here as well. And so there's more and more of a movement in the Kriegsmarine towards, no, we know what we're doing. Other people are asking us for how we do it. And only a few people going, we probably still could use some tips from allies who have actually got a little bit more shipbuilding experience than us at this point. Mostly Italy. But they got kind of drowned out for the most part. And to be fair, the Italians had reason to be cagey with the Germans because, well, the Italians were asking for various bits and pieces, like in the early to mid part of the war, asking for information and or potential trade for German surface and air search radars. Didn't really get anywhere because limited manufacturing capacity, and the Germans were determined to keep the secrets for themselves. Almirante Brown asks, could the Imperial Japanese Navy have instituted an effective submarine blockade of British India in 1942 and 43, using the captured ports in the Dutch East Indies as supply bases? And if so, how would this have affected Britain's overall war effort and the deployment of Allied anti-submarine warfare assets across the different naval theatres? Realistically, no. And that's for a few reasons. Firstly, British India is quite big. There's a lot of ports, and you'd need a lot of submarines to do that. And of course, you kind of have the rule of threes. If you want to do a proper submarine blockade, you're going to have, for every submarine on station, another submarine either coming to or from station, and another one in resupply or refit. And while the Japanese do have a fair number of submarines, they don't have that many, especially considering that the Japanese submarine arm is already very heavily committed to the Pacific War against the US Navy. And in, 42 and 43, let's just say their submarine arm is suffering a little bit from the attentions of the US Navy. And given that if they did deploy into the Indian Ocean in force, they would then also be suffering from the attentions of the Royal Navy and the Royal Australian Navy, who have considerably more submarine hunting experience at that point in the war than the US Navy does. It's not going to go well for the Japanese submarines. So basically, they don't have the free submarine strength to actually meaningfully blockade the whole of British India. And what strength they did commit would be fairly rapidly depleted if it was actually seen as a serious threat. Now, obviously, the Japanese did deploy submarines to the Indian Ocean, as did the Germans, interestingly enough. And they did score some reasonable kill streaks, but that was partly because they were scattered all over the Indian Ocean, so very difficult to concentrate forces against. And also simply because, while they got individually pretty nasty kill streaks for the Allies, there weren't a huge number of them, so they never posed a significant existential threat to the Allied war effort in the Indian Ocean, and therefore existing demands in the Atlantic for the British and the Pacific for the Americans meant that not a huge amount of anti-submarine warfare assets were sent to the Indian Ocean. If the Japanese do end up sending any substantial submarine force into the Indian Ocean to the point where it's beginning to look like they might have at least a partially effective blockade, perhaps of the east coast of India, then that will force the Allies to commit additional escorts. The interesting thing is, where are those escorts going to come from? Because it's technically a British area of responsibility, but the pressure relief would be in the Pacific. So perhaps what might happen is, with fewer Japanese submarines in the Pacific, you might see some US escorts transferred to the Atlantic to bolster the US escort effort there anyway, which in turn would release British escorts from the Atlantic, which could then move over into the Indian Ocean. So obviously, more submarines in the Indian Ocean has a deleterious effect on Britain's overall war effort and would force a redeployment of Allied anti-submarine assets. But I think the impact on the Allied effort versus the impact on the Japanese submarine arm, once those additional ASW assets show up, is probably going to be a net in the Allies' favour, because you're not going to have the Japanese subs in the Pacific. And obviously, while the Japanese submarines weren't able to stop the American advance in the Pacific, they were able to score quite a number of damaging and fatal shots, and perhaps some of those don't happen this time round. John E. asks, did the Germans share their homing torpedo technology with the Italians or the Japanese? I assume the Allies shared theirs. So yes, the Allies did share tech amongst themselves. More specifically, the Americans invented the Mark 24 Fido, officially mine, in actual fact, acoustic homing torpedo, and they shared it with the British, so they would both use the same weapon. As far as the Axis sharing with each other, well, the very first German acoustic homing torpedoes weren't really ready for service until the first third of 1943 was concluded, which essentially means the Italians, even if the Germans were willing to share, were never going to get their hands on them, because of course within half a year of that the Italians had bowed out of the war officially. So sharing with the Italians isn't on the table, although the Italians were making steps towards developing their own acoustic homing torpedoes. And then similarly with the Japanese, the Germans and the Japanese weren't really all that much into trading technology with each other right up until the latter stages of World War II. And in fact, when the very, very first submarine technology trade missions started up in 1942, first it was strategic materials, and then when it got onto equipment, you actually had the Japanese trading torpedo technology to the Germans first in the form of, an aerial torpedo that actually worked, and later on also offering them examples of the 21-inch submarine-launched oxygen-fueled torpedoes. Later on, attempts were made to send some German electrical torpedoes over to Japan, but it doesn't seem like they specifically ever sent acoustic homing torpedoes, and much like Italy, towards the end of its part in World War II, Japan was experimenting with acoustic homing torpedoes, but it seems to be a largely homegrown effort. Scooter JSP asks, I remember that various navies attempted to use submarine cargo transports during various conflicts, but it was only ever for small, high-value cargoes. For more general bulk cargo transportation, it was deemed impractical for the amount of goods that could be carried by available submarines, but could a viable cargo submarine have been made if it were designed from the start to be a cargo vessel intended to haul materials comparable to a surface ship, with the designers approaching the challenge that the cargo would take longer to reach its destination, but perhaps would be more likely to reach it? Well, yes and no. Could you design a really big cargo submarine to move substantial amounts of goods? Yes. Is it ever going to be comparable to a surface ship? No. And that's for a few reasons, at least in the time period the channel covers. Firstly, your machinery space is going to have to be a lot bigger than you would have on a regular cargo ship, because you need your surface propulsion system and your underwater propulsion system. So 2 separate sets of drives and obviously quote-unquote fuel, if presumably you're going to use diesel for the diesel engines on the surface, but then you would also need battery storage. So that's going to take up a lot more space than the fuel and machinery spaces would take on a normal cargo ship, thus making your design less efficient. Next, you've got to have a pressure hull because, you're going underwater. And between that and the hull casing and the ballast tanks and so forth, so that you can actually go under the water with some measure of control, well, again, that's all a whole lot of extra weight that a cargo ship doesn't have because, well, a cargo ship just needs a hull. It's not supposed to be going underwater. Then you have your life support systems, compressed air, CO2 scrubbers, etc., etc. Again, not really a thing that you need on a surface vessel because it's, well, in the air and hopefully stays there. And you're probably going to need more fuel because ultimately, no matter what your hull casing is like, it's not going to be as efficient moving through the water as a dedicated cargo ship's bow is going to be. So your miles per gallon is going to be less. And then looping back around to the pressure hull, well, you've got 2 choices. You can either make the pressure hull really big to carry stuff internally. That's going to run into issues because the thickness of pressure hull that you have for a submarine that's, say, got a 20-foot diameter pressure hull, well, if you scale things up and you have, say, an 80 or 90-foot diameter pressure hull, that same thickness of pressure hull is not actually going to get you down to the same depth. Now, yes, pressure per unit area is going to be the same, but unless you seriously beef up your internal structure, the overall amount of force being exerted on the pressure hull is going to increase because, well, if your pressure per unit area is the same and you have a much greater area, that's a lot more force. So you're either going to need a thicker pressure hull or very strong internal structures and very closely spaced ribbing and so forth, or both, potentially. Of course, you can obviate some of that by building a sub that's not going to go very deep, but then you're sacrificing a lot of the more survivable and stealthy aspects of your sub. And even then, you can only afford to have certain sized openings in your pressure hull, which is going to limit what you can take internally in terms of hard items like aircraft and so forth, and it's going to limit your input and output volumes for stuff like liquids or stuff like powdered goods, grains, minerals, that kind of stuff. The other alternative is to have a smaller pressure hull, an absolutely massive outer casing, and have some kind of cargo pod in between the casing and the pressure hull, which theoretically should preserve items dry, but then you're limiting what you can take to, well, how big are these pods that you can fit within, because you don't want to have an absurdly large gap between the casing and the pressure hull. And there's a possibility they might leak. There's no real way to control the environmental conditions inside in terms of condensation and things like this. So you can't put anything really sensitive in there unless you absolutely pack it with something like cosmoline and grease. And with all these additional systems, the whole thing's going to be ridiculously expensive compared to a normal cargo ship. So compared to your average cargo ship, could you make a submarine that in theory might be able to transport, let's say, 7,000 to 8,000 tons of cargo? I mean, yeah, it's probably not outside the realm of technological possibility in World War II, but it would be colossally expensive. You could build a fleet of cargo ships for probably the same amount of money, and then that leads you to the problem of, well, not only do you have much less flexibility with your one monster cargo sub compared to a whole fleet of cargo ships, but also if you lose that cargo sub, even though, yes, technically is slightly less likely to be lost, that's it. It's done. You're done. Whereas if you built, say, half a dozen cargo ships instead, well, you could lose half of them and you still got 3 cargo ships, which is still 3 times more cargo capacity than your one sub ever was going to be. And the reason I say in the time period the channel covers is that economies of scale do apply. So in theory, although it would still be fairly inefficient, a modern cargo submarine for kind of medium scale goods might be somewhat more viable than it used to be in the time period the channel covers, but you're definitely not competing with the bulk goods carriage with submarines these days, because, well, I think the ultra large carriers and so forth have kind of got that market cornered, and no one's building a 100,000 ton plus submarine. Warrant Officer Will asks, as you've discussed before, the US Mark 18 torpedoes is essentially a copy of the German G7E, with Buord's interference making it slightly worse, but this is a rather rare example of rapid reverse engineering in World War II. My question is, could this have been done with any other torpedo? Particularly if the circumstances had been different and the various racist biases circumvented, could the US have made an oxygen torpedo based off of the Type 93 either during World War II or at the very least by the early Cold War? Well, I think the question would be, why would you want to do it to any other torpedo? You certainly don't want to reverse German air-launched torpedoes unless you just want a really good laugh. And generally speaking, actually coming across torpedoes that you could reverse engineer is actually relatively rare out of very, very specific circumstances, like, say, the Guadalcanal campaign or the German campaign off the US East Coast, because most of the torpedoes that end up fired in the war are fired out in deep water, and they tend to just sink if they miss. You have to have a very select set of circumstances where enemy torpedoes are fired close enough to a coastline that you control that you can then fish out some spent torpedoes. I mean, self-destruct mechanisms, if they have them, need to fail, and you also need relatively shallow sloping beaches to allow the torpedo to come to a full and complete stop without, hitting something hard enough to set it off. And then, with all that said, while obviously everybody has different capabilities of their torpedoes, a lot of the time those capabilities are a reflection as much of design choices as they are of technological capabilities. So, could everybody build an equivalent to everybody else's torpedoes, at least roughly speaking, if they wanted to, with the exception of something like a Long Lance? Yeah, probably, but they didn't, mostly because they didn't want to. Either that or the performance would have been close enough that it's not worth building a whole new batch of torpedoes just for some marginal changes here and there. Now, of course, the oxygen-based torpedoes, the Type 93, Type 95, etc., Those are a somewhat different question because, of course, they have a very high speed and a very long range, which is far in excess of anything that the Allies really have. But you've got to get, I think, two big hurdles to overcome in order to develop your own oxygen-fueled torpedo. Firstly, you've got to recognize that it is an oxygen-fueled torpedo, because obviously by the time you've recovered it, the oxygen has gone. It's been used to propel the torpedo, at which point what you have is a tank that holds compressed gases to help fuel the torpedo. Well, that's kind of a standard feature. The Japanese have done it slightly differently in appearance to the way you would have done it, but hey, that's why different nations have different technologies. So you've got to find someone who actually recognizes that this is, in fact, an oxygen-based propulsion system in the first place. And then, once you've done that, could you reverse engineer it? Yeah. Would it be quick? Not necessarily, because, of course, the Japanese did quite an extensive amount of experimentation to get to where they did with oxygen-fueled torpedoes that didn't, self-ignite or self-detonate the minute you tried to fuel them up. Now, you could take a very Soviet approach, like when the B-29s landed in the Soviet Union and you get the Tupolev 4, and just go, this, here is a thing, you will replicate the thing to the exact specifications, shape, size, and tolerances of what it already exists. And that way, yeah, you probably could, by, I would say maybe, if you, let's say, pulled a long lance off the Guadalcanal beaches, maybe by 44, you could have reconstructed the system and presumably put it in a slightly smaller package, so you can fit it into a 21-inch torpedo, like the Type 95 was, and then gone, right, now we have long-range oxygen-fueled torpedoes of our own. But you've then also got to build the infrastructure, the oxygen-generating equipment, the oxygen storage equipment, the way of fueling the torpedoes. That's all additional stuff you're going to have to discover how to manufacture and, operate safely. And then on top of that, you've got to just absolutely hope that the Bureau of Ordnance doesn't decide to try and improve things the way they tried to improve the G7E into the Mark 18, because given the Bureau of Ordnance's track record in designing and improving torpedoes in the interwar and early World War II periods, if Buord tried to reverse engineer a long lance, they'd probably just blow themselves up. But if saner heads had prevailed, I think it's possible by, let's say, mid to late 44, maybe early 45, if someone had pulled a long lance off of the Guadalcanal beaches and identified it as an oxygen-fueled torpedo, and someone had decided, yes, we actually want this feature, that the Allies could have been fielding some variant of their own. In this particular case, I think actually it would have been better off to just lob the torpedo over to the British, because the British had already built enriched oxygen-fueled torpedoes with the ones that were aboard the Nelsons, so they would have a little bit of a head start in understanding some of the finer bits of engineering, like making sure the internals are very, 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 very clean so you don't get spontaneous combustion. Redosaurus asks, if France had kept the Richelieus, how hard would it have been to install VLS at the back end? Well, if we're assuming that you're keeping somehow a Richelieu around until, I guess, the mid to late 80s, when VLS kind of really becomes a thing, then it could be done. There would be a few rather big complexities to it, though. So in terms of the aft area, you'd basically be looking at the area that's dominated by the hangar for the aircraft and the, as installed, the secondary battery. So those three turrets you can see right aft. Now, the reason I say that you'd be looking at that kind of area, so basically from just forward of the 40mm gun nest you can see right at the back to about just behind the funnel, is that area doesn't contain anything significantly vital to the overall running of the ship for the first few decks. It's mostly to do with, shocking enough, the ammunition supply for the secondary guns and various bits of accommodation for stuff associated with the aircraft facilities. It will impinge somewhat on crew facilities, but you're also going to be, losing a bunch of crew from the hangar and from the secondary guns. So it probably balances out. The bigger issue that you're going to have, or I think the biggest issue, is that if you go down from where the two secondary turrets are, the port and starboard ones, the central ones a bit higher up, you only go down a relatively brief journey before you hit the armor deck. And that's not enough to fit a VLS like a Mark 41. You would have to extract the secondary battery and then either accept, let's say, 3 very small VLS arrangements, basically down in what had been the barbette for each of the secondary turrets, maybe expanding a bit more in the area on the platform that the upper turret had been on, or you would have to go in and cut away significant portions of the aft armor deck, perhaps lowering the armor deck down one level, which actually might make a certain amount of sense, because if you did lower the armor deck down one full deck, yes, you'd end up with a step in the armor deck around the area of the funnel, which isn't great, but it would also mean that if anything happens to the missiles, you've got the armor deck to protect the turbo dynamo system, etc., that's down in that particular area, which would probably be a good idea. But you would have to do some fairly major surgery to the stern of the ship in order to accomplish that, because you're going to have to cut through all the stuff that's there, cut away the armor deck, cut away what's immediately underneath that armor deck, and then put the new armor plate in. The good part about that would be then once you rebuild that section of the stern, then you would have quite a large area in which you can install VLS, and at that point you'd actually have the sort of 22 to 25 feet or so that you'd need to install a VLS system that would just come up to what had been the deck level where the 2 secondary turrets are, and you probably actually save a little bit of weight and stability, because then you don't need that little pedestal stand that the central secondary turret sits on. So yeah, it could be done, but it'd be very, very expensive. Probably not as expensive as building a destroyer from the start that could fit that many VLS cells, but there'd be a fair few francs being spent. Corky asks, in your video on the King George V class battleships, you mentioned that one of the considered designs was armed with 3 triple 15-inch guns, but they opted against that from a combination of treaty restrictions for Second London, past teething issues with the triple 16s on the Nelsons, and the need for the development of an entire new turret. Could that development stage have been shortened or obviated by either just downscaling the existing 16-inch turret design, or simply building the same size turrets but fitting them with 15-inch guns? Or were there other considerations that pushed the Royal Navy away from a triple 15-inch design? Given the overall weight of the Nelson 16-inch turrets, and the fact it's relatively favourable with other turrets of approximately the same size, scale and firepower, there may be some benefit, at least on paper, in just taking the existing Nelson class turrets, maybe shaving them down a fraction. I mean, you're not changing the overall diameter of the guns all that much, and then just putting new 15-inch guns in. But you would be facing a few issues. Firstly, I don't know exactly what the weight of the Nelson's turrets would have been by that point, because we know what the weight of them was as designed and as implemented, but there were all sorts of various fixes that were put in post-fact to, resolve some of the issues. So that might push the weight up a little bit. But I think that much, there's probably not a huge amount per se against just reusing the existing Nelson design. The big problem there would have been that, well, you're still designing a ship to 35,000 tons. So yes, you could do it, but pretty much everyone would have been looking at it and going, yeah, but if we built one new, we could maybe save 50 to 100 tons or more per turret. And, well, multiply by 3 turrets, 150, 300 tons, that's that's actually quite a substantial amount of tonnage you could use somewhere else. So yes, you could probably have done it with relatively minimal changes, but in the time period when you're trying to squeeze every last bit of efficiency out of your treaty era design, they just wouldn't have. Plus, of course, there was new technology to be incorporated and so forth. But by the mid-1930s, you've got the treaty restrictions that are being proposed with the upcoming London Naval Treaty. You've also got the fact that, well, 3 triples are nice, and ultimately, personally, I'm of the opinion that a King George V class with 3 triple 15s of a brand new design actually would have been the optimal choice. But at the time, one of the considerations was, well, if you have 9 guns, you get 9 shots at the enemy per volley. If you go with quad 14s, you get 12 shots, which is 3 extra shells, which is 3 extra chances to hit, which, if we're fighting at the mid-teens, the penetration differences probably doesn't make too much odds. So there was a certain logic to why the Royal Navy backed off from the triple 15 design, apart from the desire to have 14-inch guns included in the upcoming London Naval Treaty. In hindsight, I think they were a bit mistaken in this, but that's hindsight. Ian Carr asks, were other locations seriously considered for the East of Suez dockyard, such as Mombasa, Aden, the Persian Gulf somewhere, or Bombay, now Mumbai? And was the final location decided in conjunction with the Simonstown dockyard development? The Simonstown naval dockyard development actually predates Singapore by about 2 decades or so. Simonstown, really kicks off its big naval development in the late 1890s and early 1900s, and there's some tentative indications that it would have been much, much larger had the nascent Imperial Federation project gone forward around about that time, whereas Singapore only really starts significant development into a major naval base in the late 1910s on paper and 1920s in earnest, and even then it's somewhat delayed. And the reason for that is, well, twofold. Partly, previous dockyards in various places around the Indian Ocean and the Western Pacific could handle ships of the size and scale that the Royal Navy used at that point. Obviously, by the 20s, you needed somewhat larger dockyards because of the much greater size of new warships. But the other factor that came into play was that for the 19th century, and even for the early part of the 20th, the very first decade or two, the Royal Navy doesn't really see a need for a very major dockyard east of Suez, because they assume that the only navies that can really challenge them are European navies, and perhaps very latterly the United States. And the thing is that, well, the European navies can be better contained in the North Sea, the North Atlantic and the Mediterranean. They're unlikely to have any major fleet presence in the Indian Ocean or the Western Pacific, so you don't need a dockyard that can support an entire fleet there, because you're not going to need an entire fleet there. There's theoretically potentially some concern about the Russians, but the Russian Pacific presence is historically relatively small. They try and build it up in the late 1800s, early 1900s. Then the Japanese deal with that rather decisively, so that's not a problem. The Japanese potentially could be a problem, but in the 1900s and 1910s, Britain is allied with the Japanese, and the US is on the other side of the Pacific, and also, again, alliance with the Japanese. So you don't really, again, need a major dockyard. Simonstown is quite useful because it's a good stopping off point in terms of British commitments around the globe. But further east of that and the Suez Canal, there's no pressing need for a major fleet base. In the Indian Ocean, there's no one who's going to challenge you. And then when it comes down to the Anglo-Japanese alliance breaking down and they have to start actually thinking about potentially guarding against the Pacific, then, well, you've got Weihai Wei in China. Okay, that's far too close to Japan. You've got Hong Kong, somewhat further away from Japan, but still probably the British side a little bit too close for comfort. Then you have Singapore, and then, of course, you step back to places like Ceylon, the Indian subcontinent itself, and so forth. And essentially with Singapore, seems to be the best balance of nice big natural harbour facilities, relatively defensible terrain, and far enough from the Japanese that you should get decent warning and have some ablative armour in terms of other territories against direct Japanese occupation, but close enough that you don't have to worry about major fueling and refueling issues once your fleet leaves the port and sails out to fight the Japanese. That would be the major problem with developing somewhere like Bombay-Mumbai or Ceylon, now Sri Lanka, is that, yeah, you could build a Singapore-style naval base there, but then you'd need a Singapore-style naval base in Singapore or Hong Kong to replenish, refuel, and repair the fleet as it moved forward anyway. And you've also got to account, obviously, for repairs coming back. If a fleet sails from Singapore, fights the Japanese in, let's say, the South China Sea, and then some ships have to come back for repairs, coming back to Singapore for repairs is a lot more viable than having to go all the way over into, the mid-Indian Ocean. Killer Rabbit asks, from what I can tell, there are two main variations of the Baltic Project, cutting off German trade with Sweden or invading Pomerania. Which plan do you think works best? Definitely the cutting off the trade with Sweden, mostly because of those two options. That one is actually doable and marginally less insane. I mean, attacking neutral shipping in the Baltic probably isn't going to end too well in any case, but, as I said, of the two, well, landing troops in Pomerania, and you're probably likely to lose a good chunk of the fleet you send in, and probably the troops as well. Whereas, at least if you try and only, in quotation marks, cut off trade with Sweden, you can do that with a much smaller force, probably destroyers, a few small cruisers, and some submarines. And one, you're much more likely to actually get those through into the Baltic with minimal losses. And two, that's the kind of force that could actually be sustained basing themselves out of Russian ports, at least as long as Russia is in the war. And so they could continue their raiding activities. So simply on the grounds of plausibility, going after the Swedish trade of the two would be the one that I'd pick. Daniel Geaton asks, I remember reading in a book on submarines that during the First World War, Germany built some, for the time, very large submarines in an attempt to use them as cargo carriers, I assume to try and break the British blockade. How many of these were built and how effective were they? And have there been other similar attempts during the Second World War? So these are the Deutschland-class cargo submarines. The Germans did initially intend to build quite a few of them, but as far as cargo submarines are concerned, they only ever actually end up building two, Deutschland and Bremen. Bremen went missing on her first voyage, so only Deutschland ever actually did the cargo thing. But a number more were then built as U-Kreuzer, long-range attack U-boats, mostly because the whole point of these submarines was to trade with the US, and by the time the 3rd, 4th, 5th, 6th and 7th submarines were anyway close to being finished, well, the US had entered the war on the side of the Allies, so they clearly weren't going to be trading with them anymore, and Deutschland was in fact converted over to this setup as well. Now, their ability to break the British blockade was somewhat limited, because even though, as yet, for the time, they're very large submarines, they're still not particularly large as far as merchant shipping goes, and as I've discussed before on the Drydock, there are limitations to the amount of cargo that a given ship can carry if it's a submarine versus a similar size vessel as a surface ship. So the Deutschlands could carry 700 to 900 tons of cargo, with sort of 700 or just over that tonnage, depending obviously on density, being dry cargo, i.e. cargo that could be stored in the pressure hull or in watertight compartments, and then another 150 to 200 tons of cargo could be carried in compartments between the inner and outer hull that would nonetheless flood. So if you didn't mind the cargo getting a bit wet, like say rubber, then you could add some additional cargo to your trip. Now, with that limited cargo capacity, there was no chance these submarines were ever going to fully break the British blockade. Germany needed a lot of items in bulk, things like natural base ingredients for explosives. They did obviously invent the artificial processes to make explosives anyway, but it would have been cheaper and easier to use naturally occurring ingredients. Food, obviously, is a very large bulk item, and these other kinds of large-scale supplies, you're just never going to fit any meaningful amount in the subs. What they could transport were low-volume, high-value cargoes, particularly, essentially, things that you could cut down or dilute and get a huge amount of use out of. So some of the things that they transported were dyes in incredibly concentrated formats, raw medication, again, in very concentrated formats. It's stuff that you actually only needed a very, very small dose of, but obviously in a concentrated format, you could transport thousands or tens of thousands of doses in a very, very small package. And also strategic metals, because, for example, if you're trying to make gun barrels for artillery, you might need small, very small amounts of various what you might call trace metals, at least as far as the alloy is concerned, that don't naturally occur in German-held territories. So you might only have a few hundred tons of that kind of metal on board the sub, but those few hundred tons of metal might then, when combined with carbon and iron, allow you to build thousands or tens of thousands of tons of high-grade steel implements, whether that be artillery, rifle barrels, whatever, maybe even machine tools. And in that regard, I mean, the voyages that Deutschland completed more than paid for her cost, which in the abstract is a good thing. Whether or not they ever stood a chance of redressing the German balance of lack of strategic materials is another. Probably not. It's sort of drip feeding things in. They really, I think, if they were going to break the blockade on at least these high value, low volume strategic materials, they probably would have needed the whole fleet. And of course, the activities of other German U-boats meant that the whole endeavour was pretty pointless soon anyway. In World War II, there were a number of attempts at cargo submarines to varying degrees. Most were just using existing submarines that happen to have fairly large carrying capacities for one reason or another to move cargo instead of some or all of their weapons. So, for example, the British used some of their big mine-laying Rockwell-class subs as temporary cargo subs to supply Malta. The Germans and the Italians both also put some of their active duty subs to that purpose, and of course the Japanese as well, trying to supply Guadalcanal, use some of their big subs as supply haulers, but they weren't specifically designed as cargo subs. The Germans did design the Type 9 D1, which was an unarmed cargo sub intended to go to Japan, but there is also a little bit of a grey zone in that with the Type 9 D2 and some of the Italian subs, there were some subs that were designed either primarily or specifically with the capacity to haul cargo, as opposed to kind of retrofitting pre-existing designs, but they also carried a defensive armament. Now, of course, a defensive armament on a merchant ship in World War II is far, far more common than on World War I, but when it comes to those subs, it's kind of down to the individual to draw the line at, is this a cargo submarine that happens to have a defensive armament, much the same as a Liberty ship is a cargo ship that might happen to have a 5-inch gun or two aboard, or is this a combat submarine that happens to also have some capabilities designed in to carry cargo? And in that respect, personally, I would suggest that a submarine that perhaps carries some deck guns and anti-aircraft guns to defend itself on the surface long enough to submerge, but doesn't carry torpedoes, probably would count as a cargo sub, whereas a submarine that does have torpedo tubes, which are necessarily purely an offensive weapon, for the most part, would count as a combat submarine that happens to carry cargo. Mikko Leitner asks, is there any individual Allied merchant ship or warship on a transport mission whose loss to the U-boats hit the Allies particularly badly because of an irreplaceable cargo? Well, I guess it depends on how you treat the word irreplaceable cargo, because obviously you could talk about irreplaceable cargo in terms of human lives. What was the single greatest loss of life? Because obviously people can't be replaced. They're all unique. except for that one guy in Life of Brian. Now, you could also look at it in terms of most valuable, something carrying vast amounts of precious metals, like HMS Edinburgh here. But ultimately, while those hurt the ledger of the Allies, they could always find more money. That was kind of one of their superpowers. But if you mean sort of something that absolutely could not be replaced in any way, shape, or form, or was really inconvenient and difficult to replace, as far as I'm aware, there were certain ships that were sunk with stuff whose loss in the short term would be a very big problem. Things like aircraft heading over to Britain during the Battle of Britain, or aircraft parts, that kind of thing. But ultimately, they are not in and of themselves unique items. They can be replaced. It's just the time it would take to do so. Well, bad things could happen while you're, fighting a battle with the Luftwaffe, for instance, if you were counting on that particular supply ship to bring you certain things that you needed for that fight. But in terms of something where you're looking at as cargo, it's like, well, that's gone. We can't replace it. We now have to find a way around this problem. And this could set back our efforts by months, possibly years. As far as I'm aware, that didn't happen. The closest I can think of would be stuff like uranium ore for the atomic bomb project, the Manhattan Project as it was initially. Obviously, bits for the atomic bomb as well. Those were the kind of long lead, near unique items that could completely throw us in a schedule out of whack and would take months, again, if not years, to replace, depending on exactly what was sunk. But the Allies knew what was essentially irreplaceable and what was merely inconvenient, and the stuff that was really irreplaceable tended to sail under all sorts of special circumstances. So as far as I'm aware, I don't think any of those ships were lost. Obviously, the Indianapolis was sunk shortly after it transported atomic bomb parts, and if it had been lost, a month earlier, it could have been a big problem, but that they managed to dodge that particular bullet, or torpedo, more accurately, just long enough. Nathan Redder asks, how effective could thermobaric weapons be against warships? Is there any way to make such a weapon that could penetrate within a ship while still being able to split open, dispense fuel, and ignite? And is a warship at battle stations too compartmentalized for this to have a large enough effect? I think it depends very much on what kind of ship that you are targeting. If you were going after a very, very lightly protected, or essentially from the perspective of a World War II battleship, unprotected ship, so a World War II destroyer, maybe modern warships, depending on what protection levels they have, but nowhere near as much in terms of physical defenses, then you probably could make a thermobaric weapon with at least a semi-armor piercing head that could potentially have its dispensation and react, and then its secondary detonation systems actually survive penetrating at least some armor. I mean, I don't know a lot about modern thermobaric munitions armor piercing capabilities, but it seems like the kind of thing that would probably get some very vital internals rather smashed up if it had to undergo a several hundred G deceleration from smashing into a massive great lump of steel like a bit of belt armor. With that said, if it actually gets inside, thermobaric weapons are known to be extremely effective in confined quarters. So obviously, a compartmentalized ship would be extremely confined quarters, which in turn would suggest they would be very effective at blowing big holes in the ship, which is obviously the general objective of dropping bombs and firing shells at something. However, if we go with the assumption that a thermobaric weapon would not be a particularly useful thing to use against a heavily armoured target, i.e. let's say a battleship or a large cruiser, then in theory, if they'd managed to develop what we would understand as a modern thermobaric weapon back in the time period the Channel covers, there would still be two rather significant potential uses for them. Firstly, because basically both of them rely on the fact they generate a very, very violent, very large explosion for their size. essentially use them as massively uprated HE or general purpose bombs. So you hit the ship with them set to detonate pretty much instantaneously, and the shockwave that they would create would be able to either, or possibly take out sensors, so smash rangefinders, destroy radar, etc., basically blind a ship and leave it unable to continue combat. And even the rangefinders found on the battleship's main turrets may still be vulnerable to having their viewfinders or lenses cracked by the shockwave. And separately to that, or again, potentially as well as exposed mountings, so your light and medium anti-aircraft, maybe even some of your heavy anti-aircraft mountings, and the crews for those mountings, they may all be subject to some rather deleterious effects of being hit by thermobaric weapons. So in the context of the time period the channel covers, or perhaps even in the modern context, you could strip a warship defenseless from further air attack by blinding it and rendering most of its anti-aircraft capability out of action. At that point, in theory, looking at a World War II ship, the machinery spaces should still be online, the main guns will still be online, but now you can basically attack it from the air pretty much at will, like a training exercise. And even in a surface-to-surface action, a capital ship that's been hit by multiple heavy thermobaric weapons probably can't shoot back very accurately, if at all, because they just can't see you. Brian Stevens asks, how significant was crew quality versus ship design in deciding battles in the Age of Sail? And in your mind, is it any different in importance as ships get more technologically complex as things move into the mechanized age? Crew quality could be the single most important factor during the Age of Sail, because ultimately pretty much everything on an Age of Sail vessel had to be done manually, and so the potential for impact in crew by having a good quality crew or poor quality crew was pretty much present in every single thing that ship actually did. Everything from the ship's trim to the amount of sail it's set, to how fast it can change those sails, to how fast it can adapt to changing weather and sea conditions, to how quickly they can reload the guns, to how much they're actually going to be likely to stick at the guns once combat gets going. Everything depends on crew quality. And obviously, if you have extremely lopsided matchups, like, first rate versus sixth rate, there is only so much you can do in those circumstances. But assuming that you are on a par with each other, approximately speaking, so say third rate versus third rate, or the difference isn't too great, let's say a large fifth rate frigate versus a fourth rate, or even potentially a small third rate, or a small sixth rate versus a fifth rate, or something like that, then your crew quality can absolutely make you the victor, even if on paper you should either have a score draw or you should lose. Now, crew quality does remain a hugely important factor even in the mechanized age. That's why you have ships like Renown having a reputation as being a crack gunnery ship and having performance above and beyond almost any other capital ship in the Royal Navy. However, I would say that the more advanced the technology aboard a ship gets, it's not that at the upper end, a really, really high quality crew can't make a difference. They absolutely can. But at the lower end, assuming that the crew are, at least basically competent. If you take a 5 out of 10 as the strict average, if you assume the crew is at least a 4 out of 10, because anything below that and you kind of basically dragged people off the streets and given them a ship to operate, the presence of more and more advanced technology basically raises that skill floor. Because you literally could drag people off the streets in the Age of Sail, but explaining at least some basic duties aboard an Age of Sail ship didn't take too long, which technically made them capable, just not very. So you could end up with a ship that could move around and give an opening broadside, but everything would very quickly collapse. Whereas with a technologically advanced ship, there is a higher level of training that you need just to get the thing out of dock. Which means that if you have a warship that is actually somehow functional and at sea in, let's say, the early to mid 20th century, the gap between that ship being operated by a relatively poor crew and the same ship operated by a really, really competent crew is somewhat less than the gap between, let's say, a third-rate ship of the line operated by a really incompetent crew or a really competent crew. And so the disparity which a competent crew can make up becomes smaller. So, for example, in, let's say, World War II context, a really good 6-inch gun cruiser crew could probably win against a poorly led, poorly trained 8-inch cruiser crew, assuming a generic 8-inch and a generic 6-inch cruiser, light and heavy. But it will still be a fairly significant uphill struggle for them. If their heavy cruiser is reasonably armoured for its class, for a heavy cruiser, it's still going to be able to shrug off a decent number of 6-inch shells, no matter how quickly or how accurately those 6-inch shells are fired at you. And the same thing with a battleship. If you're engaging a battleship at 20,000 yards with a heavy cruiser, no matter how good your crew is, if that ship has 12, 13, 14 inches of armour, there's very little your 8-inch shells are going to be doing to their citadel or to their gun turrets unless you get stupidly close. Now, having a very bad crew and a very good crew might allow you to get stupidly close, but all the way in, all the poor crew needs is one lucky salvo and you're pretty much done. Where you can, I would say, mostly see the advantage of a particularly skilled crew versus a less skilled one is when the combatants are otherwise, roughly speaking, on a par. So destroyer versus destroyer, light cruiser versus light cruiser, heavy cruiser versus heavy cruiser, capital ship versus capital ship, carrier versus carrier. You know, at that point, when in theory both sides have the capacity to hurt each other, even if one is perhaps at a disadvantage on paper compared to the other, that in the more modern technological era is where having a really good crew will give you an not entirely but near guaranteed win against a similar or possibly technically slightly better example of that ship class, but with a bad crew. Seb Dove asks, could you please expand on the efforts to recover downed RAF and Fleet Air Arm aircrew in the Channel by the Royal Navy and Coastal Command throughout the Second World War? Well, that's a subject that easily could make a very long Wednesday video, possibly actually even a small mini-series into and of itself. So very, very briefly, over the Second World War, the rescue efforts in the English Channel consisted, at varying points, of essentially three major arms. First, you have the high-speed launches. You can see one here, and if you would go down to Portsmouth Dockyard, they've got a preserved one there as well. As the name suggests, these are essentially extremely high-speed powerboats with some minimal defensive armament, but their primary objective is that if a pilot is reported as having gone down, either he's reported himself or someone on the coast has spotted him, or one of his squadron mates has spotted him, or a recon aircraft has spotted him. Basically, if anyone says, hey, there's a downed pilot over there, these things were designed to zip out as fast as humanly possible, get out there and haul the pilot or possibly pilots, if you'd had a fairly intense air combat, aboard and get them home and treated. Of course, as with any high-speed small craft, they are subject somewhat to weather limitations, but being a boat, they do have a bit of a sort of a grey area margin where if the weather is bad but not too bad, they can still head out just at a somewhat slower pace. And in the context of World War II, if the weather is absolutely awful to the point they can't sail at all, they probably aren't doing flight operations. Another arm was seaplanes and float planes. Now, of course, they have the advantage over the HSLs that they can get there even faster than the HSLs can, but they are more likely to be grounded by rough weather, where fighters may have been operating or the weather may have taken a turn after the fighter went down, whereas, as I said, the HSL go out perhaps in a slightly more adverse environment. And of course, aircraft, if you've just lost a pilot, there is theoretically the chance that any rescue aircraft might also get jumped by whatever shot down that first pilot. But they, apart from the speed advantage, they also, of course, have the advantage of they can see a lot further. An HSL captain and the spotters are only going to be, a dozen feet, if that, above the water, so their radius of view is limited. An aircraft, on the other hand, can see quite far, and at least if the pilot has something very visible on them, a mirror, flare, a very bright life jacket, it might be much easier and quicker for the aircraft to spot them. In the aircraft, if they are a seaplane or float plane or flying boat, they can pop down and potentially pick them up if the seas are calm enough. If not, they can direct an HSL, say, right, you need to come exactly over to here. Or later on, they could also kick out supplies of their own, little lifeboats and so forth that could be parachuted down in the vicinity of the pilot, hopefully not directly on top of them, because that just makes a bad situation worse. And then the final arm of it was an adaptation off of the Germans, because the Germans moored a series of static rescue buoys in the areas of most intense aerial activity, which were essentially little floating apartments where a pilot, if they could swim to it or row to it with a life raft, could get on board and signal for help while enjoying calmish, dry conditions with a little bit of hot food and water and some basic medical gear. And the British eventually copied that idea, but with a slightly different format. Rather than looking like a very large buoy, it looked more like a small boat, but still brightly coloured. And finally for this week, Andrew Kirshenman asks, if Lexington and Saratoga had been completed as battle cruisers and the naming of historic US battles had stayed with a continuing battle cruiser development, what do you think the naming convention of the fleet carriers would have followed? I think there are, I would say, three possible routes for US naming conventions for their carriers had they not gone with historic battles set up. So the first one, obviously, is to draw USS Langley CV-1, obviously named after an early aviation pioneer in the States. So they could have picked that up and run with it. There is only one problem I can foresee with that, which is that you would very quickly have run into if you're using names of aviation pioneers, you would have run into the names of people who still had their names attached to various companies who were supplying aircraft to the Navy, and therefore it could be seen as favoritism. So, the Wright Curtiss Company exists. So do you name a carrier for the Wright brothers? Because then, Douglas or Northrop or whatever are probably going to come jumping up and down saying, well, that's blatant favoritism. A second option, and the one I find more likely, is that they may have just kind of skipped a few and gone with naming for ships of the Continental and early US navies. So Ranger, Enterprise, Hornet, Wasp, Essex, those names still perfectly valid and don't break the naming convention of battles, which at this point are being held for the battle cruisers. Or the other option, which I think is, okay, granted perhaps a little bit of a left field choice, but would be to adopt not quite a Royal Navy, but almost a Royal Navy naming program and use various quality terms. So instead of saying directly we're going to name after ships from the War of Independence era, the Continental Navy and so forth, take a handful of those like Enterprise and Intrepid, whose names are themselves some kind of quality, and then look for other similar names, either synonyms or related concepts, which you could then build into ship names. So, for example, if you just look, what is the synonym of Intrepid? So you could have the USS Intrepid, which you in fact did and still do for that matter, but you could have Fearless, Undaunted, Dauntless, Daring, Audacious. Now, obviously, some of those have been used by the Royal Navy, but they're all very good names. Or if you look, winding the clock slightly further forward to World War II, they were thinking about doing USS Reprisal. They ended up not, because it ended up being one of the Essex class that was cancelled. But you could also, from Reprisal as a synonym, get Retribution, Revenge, Vengeance, Avenger, etc. All of those, again, I think would make really good names for carriers. And that brings us to the end of this week's video. Thank you very much for watching, and I hope to see you again in another video in the new week, or even sooner than that, depending on how much spare time you have left to view these things. In any case, thanks for watching this one, and see you again soon.